Hey guys, today we're going to learn more about solving exponential equations. Okay, so we need to solve for x, and we have 3/4 root of 81 to the power of 2x minus 3 divided by 27 to the power of x plus 4, okay, equals 9 to the power of x. Okay, so what are you going to do here? Here I see the patterns, and I can see the 3, the 3, the 3, the 3. Okay, so what are we going to do here? I'm going to convert everything as a big 3. Okay, and foremost, I'm going to change the fourth root to 1 over 4. Okay, so at the top you have that 3 to the power of 4 is 81, and that one you have it to the power of 2x minus 3. Then on your denominator you have that beautiful 27, that is 3 to the power of 3, and that one is to the power of x to x plus 4, excuse me. Close it, 1 over 4, and this is going to be equal to 9, which is 3 squared, and to the power of x you would have that. Okay, so now you can see that everything has to do with the 3, so our base is going to be 3 for this problem. So what are you going to do at this point? Well, we need to start combining. Honestly, I'll first distribute here. Okay, so I have 3 times, and I have that it's going to be 3. 4 times 2 is going to be 8x. 4 times negative 3 is going to be negative 12. Then I distribute the 3 that I have here. 3 times x is going to be 3x. 3 times positive 4 is going to be positive 12. So I have this to the power of 1 over 4, and this is going to be equal to 2x. Okay, to the 2x. Okay, so now what are we going to do? Well, as PEMDAS, I'm going to combine this. Please remember that whatever you have here, you need to change the sign, meaning to pass it up. So I'm going to do it here so you know what I'm doing. Okay, so you have this 3. Okay, you have the 8x minus 3x because it's coming up, so you have 5x. You have this negative 12 minus 12, so that's going to be negative 24 to the power of 1 over 4. And that's going to be equal to 3 to the power of 2x. Okay, so now what are you going to do? Okay, so you have options. I don't want to work with fractions. Okay, so what I'm going to do, I'm going to conveniently raise both sides to the power of 4. Why 4? Because my denominator is 4 and I want to get rid of it. Okay, so now here when you raise to the power of 4, you need to be very careful. This 2 they cancel immediately, but this 4 is also distributing to this 3, so be careful with that. So you have 3 to the power of 4, you cancel this, so you have 3 to the power of 5x minus 24 to the power of nothing anymore. And this is going to be equal, you need to multiply that, so it's going to be 3 to the power of 8x. Okay, so here you're like, now what? Well, you have 2 3's here. Okay, since they are multiplying each other, you know by exponent properties, you are going to add the 4 to this exponent. Okay, so if you have that it's going to be 5x minus 20, because minus 24 plus 4 is minus 20, equals to 3 to the power of 8x. So at this point you are like, score, I'm almost done, because I only have one 3 here and one big 3 here, so I just need to equalize my exponents. Having 5x minus 20 is equal to 8x. Okay, so when you have that, you know that you need to have your like terms together. Having the negative 20 here, we are passing the 5x, subtracting to the other side, so you have this. After this step, you know that we need to divide both sides by 3, and boom, you are good. Okay, so this is your solution. Okay, negative 20 divided by 3, that is your solution. Okay, now let's move on to number 2, which is also pretty similar. I think it's easier, but let's see. Okay, so you have the 2 to the power of x to the power of 2, wow, divided by 2 to the power of x is equal to 64. Okay, so as I was telling you, first I'm going to convert everything in terms of 2's. Okay, so you have this guy, then we have this one, and then what is 64? Well, you know that 2 to the power of 6 is 64. So I can see all my 2's together there. Okay, so here I have two 2's, ironically. So what are you going to do? Use exponent properties. How can I use exponent properties there? You know that it's going to be 2 to the power of x squared minus x. And this is going to be equal to 2 to the power of 6. And you're like, well, this one, it was easier because I already have the bases, the 2's alone, okay, only 1, 2 on each side, so you can equalize the exponent. So you have x squared minus x is equal to 6. When you have a situation like this, immediately you need to think, well, this is a quadratic equation. When I have a quadratic equation, I want the standard form. So your standard form is going to be like this. Okay, now I'm pretty sure you can now clearly see that we can factor this equation, right? So we factor and we have that this is going to be x minus 3, x plus 2 is going to be equal to 0. So solving this equation, you know that I can do x equals 3 and x equals negative 2 immediately. So your two solutions are negative 2 and 3, and that's it. Now, for this set of equations, what you're going to see is something a little bit complicated. So what I want you to do is to make it simple, okay? So let's read it together. You have 3 to the power of 2x minus 10 times 3 to the power of x plus 9 is equal to 0. And you're going to tell me how in the world I can start. Well, let's make this a little bit simpler. Let's let your u be equal to 3 to the power of x. So what do you have if you have that u is equal to 3 to the power of x? This guy that you have here is the same as having 3x squared. So what you have here, this one, okay? What you have here in this expression is you have u squared minus 10 u plus 9 equals 0. Now that you see this, what do you think? This is a quadratic equation that you can easily factor, right? So what are we going to do? That we're going to factor. You know that two numbers that when you multiply them, they give you positive 9, and when you add them or subtract them, they give you negative 10. They are the simple number of 1, negative 1, and negative 9. Okay? So you factor this. Okay? You solve it for u. Okay? So you have u equals 1 and u equals 9. But you need to remember, what do you want to solve? You want to solve for x, not for u. So you need to replace the u for your original now that we are in a simpler situation. So you have 3 to the power of x is equal to 1 and 3 to the power of x is equal to 9. Okay? So after that, you are going to use the tricks that we were using above to solve this equation. You know that 3 to the power of 0 is 1. So I know that this is true, right? So I know that x is equal to 0, okay, for this one. Now, for this one, what are you going to do? You have that 3 to the power of x, and you know that 9 is 3 to the power of 2, so what do you have? X is equal to 2. So, as simple as that, you have your solution, 0, 2, and that's it. Okay, so let's move on to number 4 so you can see that we can do this in different ways. So for 4, you're going to tell me, well, this one is 2x plus 8 times 2 to the power of negative x minus 9 equals 0. So this one is different, and I'm going to tell you, yeah, that's right. But you know that we can multiply everything times 2 to the power of x to make it similar to this. Okay, so why I'm selecting 2 to the power of x? Because it's the base that I'm seeing, okay? It's not magical, it's the base that I'm seeing. So you multiply this times this, so you have that it's going to be very similar to this guy. So you have that it's going to be 2 to the power of 2x. Okay, then this one, when you combine these exponents, negative x plus x, that's a 0, so this one disappears. Why? Because it's a 2 to the power of 0, you see it? So you have the 8. Then this one, when you distribute this here, you have the negative 9 times 2 to the power of x equals 0. Now you're like, this is kind of messy. Okay, so this is my quadratic term, so I'm going to leave it at the front. Then I want my linear term, which is the negative 9 times 2 to the power of x. And then you want your constant term, that ironically here is the plus 8. And this is equal to 0. Okay, similarly, if you want to let your 2x be the u, you can do that. So you can do it simpler. If you automatically can do it from here, I'm okay with that. Okay, I just want you to see how I do it, so you can see that it's much simpler to see it here. Okay, so we let my u be, in this case, 2 to the power of x. So you have a quadratic equation again. So again, it's pretty easy to simplify, because you know that two numbers that when you multiply them, that they give you positive 8, and when you add them or subtract them, negative 9, you know that it's going to be negative 1 and negative 8. Okay, so you solve for u is equal to 1, u is equal to 8. After that, you go back to your u having 2 to the power of x is equal to 1, and on this side you have that 2 to the power of x is equal to 8. You know that the 1 is 2 to the power of 0, or okay, so you know that x is going to be equal to 0, and on this side you have that your 8, what's going to be 8? 8 is 2 to the power of 3, so you have that x is going to be equal to 3, and your two solutions again are 0 and 3. Okay, as simple as that. So for this one, what you have is 8 times 4 to the power of x plus 4 to the power of negative x plus 1 minus 33 equals 0. So what are we going to do here? Well, what you need to realize is this one might look a little bit intimidating, but you need to remember that using exponent properties, you know that only this guy is the same as having 4 to the power of 1 times 4 to the power of negative x. So I'm going to rewrite this equation with that, so you can see something similar to the previous example. Okay, so you have this plus, and you have 4 times 4 to the negative x minus 33 equals 0. And you're like, oh, now this example is pretty similar to the previous one that we had. Okay, so since I have this one that it's negative and this one that it's positive, what I'm going to do again is I'm going to multiply all my equation times 4 to the power of x. Okay, so I multiply this times this, so you have that it's 8 times 4 to the power of 2x. This one again, similarly to the previous one, you know that it becomes a 4 alone, because negative x plus x is going to be a 4 to the 0, which is a 1. So technically you have a 1 here that I don't need to write. Then you have negative 33 times 4 to the power of x, and then this is going to be equal to 0, because you know that 0 times whatever is 0. Okay, so obviously here I'm going to rearrange. Why I'm going to rearrange? Because I see the quadratic here, the linear here, and the constant here, so it looks like a mess. So I have this situation, and you have this here. Now you can do it with the u or not, depending on what you prefer. Okay, so if you don't want to use the u, okay, how would I do it? Well, you would have this situation. Okay, so you can factor. Okay, so using your factoring methods, you know that this is going to be, well, I'm going to use a u. Okay, u equals 4 to the power of x. Okay, so I have that this is going to be, what's going to be that? Well, it's going to be 8u squared minus 33u plus 4 is equal to 0. Okay, so if we want to factor that, what are you going to do? You have that this is going to be equal to 8u minus 1 times u minus 4 equals 0. Okay, so that's how we can factor. You could also use the quadratic formula, right? But that's too much for me. Okay, so now you know that basically your u is going to be equal to 1 over 8 and this u is going to be equal to 4, but you need to go back to your u. Okay, so what are you going to do here? Okay, so you have that it's 4 to the power of x is equal to 1 over 8. Okay, on this case you have 4 to the power of x is equal to 4. Okay, so this one you're going to tell me how in the world I'm going to do this. Well, you know that this is 2 square. Okay, so you know that 2 square to the x is 2 to the power of x, and this one you know that 2 to the power of negative 3 is going to be 1 over 8. So you equalize the exponents. 2x is equal to negative 3 here, and you have that x is equal to negative 3 over 2. On this side, you know that this one, since it doesn't have an exponent, is 1, so you have that x is going to be equal to 1. Okay, so you have that your two solutions, and let me write them here. Negative 3 over 2 and 1 are going to be your solutions for number 5. Okay, so now what are we going to do for problem number 6? Let's look at it. We have 5 to the power of 2x plus 1 minus negative 26 times x to the power of x plus 25. So what are you going to do here? Well, this one is the one that it's a little bit suspicious. Okay, so you know that this one is going to be 5 times 5 to the power of 2x. Okay, so we know that from this one. Okay, so I'm going to rewrite it here. So you have 5 times 5 to the power of 2x minus 126 times 5 to the power of x plus 27 is equal to 0. Okay, so again, if you want to use the u's, what are you going to do for this one? You have that this is going to be 5u squared minus 126u plus 25 is going to be equal to 0. Okay, so from here we can factor whatever it's your factoring method, box method, AC method, grouping. You just factor this. Okay, or you can use also quadratic formula if you prefer. Okay, I factor this, and then you have that u is going to be equal to 1 over 5 on this side, and then u is equal to 25. But obviously you are like, I don't want u, I want x. So you go back to your u. Okay, your u was 5x, so you have 5 to the power of x, excuse me, is going to be equal, and you know that that's 5 to the power of negative 1. This one, 5 to the power of x is equal to, this is 5 squared. Okay, so it's simple to see that x is going to be equal to negative 1 and x is going to be equal to 2. So you know that your two solutions are negative 1 and 2. And that's it.